All about sensation and touch and pain. So my section starts out with adaptation, which is a receptor response that can decline even as the stimulus is maintained. So adaptation is a progressive loss of response when the stimulation is maintained. So it's a progressive shift away from accurate portrayal. So it doesn't accurately portray that stimuli. So feeling something that doesn't feel the same way. Two types of receptors in adaptation are tonic response and phasic receptors. Tonic response show little or no decrease in frequency of action potentials as stimulation is maintained. Phasic receptors show adaptation rapidly decreasing the frequency of action potentials when stimulation is maintained. Suppression occurs when we sometimes need the receptors to be quiet, and it depends on sensing changes of stimuli. We depend on sensing changes of stimuli, but sometimes our body can block itself out from those, like with our eyelids or certain muscles or certain things in our ear that block out sound. Sometimes this is joined in with top-down processing, which is processing in which higher brain centers, such as the cortex and thalamus, modulate sensory info, suppressing info from some sensors and amplifying it from others. So in specific situations, amplifying it from your ears or shutting down from your ears and amplifying it in other places. Another important thing about this section was pathways, which are successive levels of nervous system process, is how successive levels of nervous system process sensory info. And sensory pathways are hierarchical tracks and stations in the brain that are combined. Each piece of the pathway handles a different portion, such as pain from the fingers leads to a reflex and then withdrawal. And most sensory info reaches the thalamus before being relayed to the cortex and then back to your body. And the thalamus is really how your reflex reactions work. Receptive fields are stimulus regions and features that affect the activity of a cell in a sensory system. These make it easier to detect edges and discontinuities on the objects we feel, and they differ in size. There's different types. So primary somatosensory cortex lies in the postcentral gyrus or the parietal cortex and just behind the central sulcus, dividing the parietal lobe from the frontal lobe, and receives info from the opposite side of the body, so mostly and a lot from the hands. The secondary somatosensory cortex maps both sides of the body and receives a lot of information from the left and right arms that are represented in the same map. Moves on to things about like attention. So attention is how do we notice some stimuli but not others. Attention is a selective understanding of stimuli and what we choose to process or not. So in the posterior parietal lobe is important in attention, and lesions here have been known to cause inattention or neglect of stimuli on the opposite side in some cats and mice. Cingulate cortex is just above the corpus callosum, is implicated in motivational aspects of attention, so what causes us to choose to pick one or the other. Sensory systems influence one another. Some organisms don't respond unless more than one sensory area is influenced. So in cats, they have cells that respond to visual and auditory, and some cats will only attack birds if they see and hear them at the same time. Touch is many sensations blended together, and the skin is a main portion of that, obviously, because it's the first thing to receive these stimuli. So it's made of an outer epidermis, which is the thinnest layer, an inner middle level known as the dermis, and the most interior level known as the hypodermis, which grounds it to the muscles. So pain, hot, and cold are detected by free nerve endings, and light touch is detected by tactile receptors. There's ridges on the skin to help catch stimulations from texture, stimulating Pacini corpuscles, which are a fast responding and fast adapting set of receptors. Meister's corpuscles and Merkel discs both detect light touch and are densely distributed in skin regions where we can discriminate fine details by touch. So like a lot of them are just in your skin, so how you feel like little things like that. Merkel's discs have an inhibitory surrounding to increase their spatial resolution, so increase the spots that they actually take. The inhibitory spots allow the spots that are feeling things to feel them with greater resolution. Meister's corpuscles are more numerous but have less spatial resolution and appear specialized. Then there's these called Ruffini's endings, which detect stretching of the skin and are large receptive fields. Then it goes on to talk about the dorsal column system carries somatosensory info from skin to the brain. Dorsal column system is a somatosensory system that delivers most touch stimuli via the dorsal columns of the spinal white matter to the brain, so of the spinal cord. The dorsal column nuclei are neurons in the medulla that receive somatosensory info via the dorsal columns of the spinal cord, and then the neurons send their axons across the midline and to the thalamus, then directed to the somatosensory cortex. A dermatome is a strip of skin innervated by a particular spinal root where it leads to a specific spot on your spine where the information will likely be um, processed. And it's a complex pattern. These are complex patterns that are easily only seen when the person is in a quadruple posture or bent over in like this form almost. Thank you.